So, a very good evening to all, and welcome to my class. Today we are going to discuss paper, right? So, I hope your paper was going good. Yeah. And in this class, we are going to see the solution of some difficult problem because I have result and I know in which question students facing some problem. Okay, so basically, particular those question I'm trying to solve in a very detailed way so that you are able to identify your mistake and next time you are able to solve such questions. Okay. Okay, so let's start with the today's session. That is the paper discussion. And this is your, I guess, second paper of JE, right? So I hope you all giving your paper in a good, good revision and by good way. Okay, so let's start with the today's session, right? Yeah. So, as the first question, that is the question number 31 from the chemistry, that is select the incorrect statement. So, this question asks out of these four statement, which one is incorrect? And this is a easy question. I guess this is not many of you can easily do this question, very easily question this type of, right? So, what the question asks basically, select the incorrect statement. Statement one is that is a boric acid is an acid because its molecule contain replaceable H plus ion. क्या ऐसा है क्या कि बोरिक एसिड एसिड होता है because its molecule contain replaceable H plus ion. Second point, boric acid is an acid because its molecule accept OH from water and releasing proton. So this one is correct, not the first one. That is boric acid, not acid just because of the replaceable H plus ion present, right? Third is silicon has a strong tendency to form polymer like silicons, okay, and the chain length of the silicon polymer can be controlled by adding magnesium silicon chloride. Yeah, this one is also correct. So in this question we have to identify the incorrect statement, right? So statement 1 and statement 4, these two statements are incorrect, right? So I hope सबने किया होगा first and fourth, that is option D. ज्यादातर बच्चों ने D को attempt किया होगा, तो जिसने भी D attempt किया है, yeah, this is absolutely correct. That is option D. Okay, that is first statement and the four statements are incorrect, right? Because the first statement says that the boric acid contain replaceable H plus ion, which is not the correct one. And the next one is silicon has a strong tendency to form polymer like silicons, and the chain length of the silicon polymer can be controlled by adding it. This is not the correct way, right? So I hope this question is very much clear to you, right? Next, move to the next question. That is the first ionization enthalpy of sodium, magnesium, aluminum, and silicon are in the order. Okay, so these type of questions are really easy, and this is from periodicity. This is 11 in your 11th class. You wrote about the third chapter, that is periodicity. So this question basically from this chapter only, right? So what to do for solving such a fun question? First of all, you need to know which element belong to which group, right? So if I'm talking about sodium, sodium is a first group one element, that is group one. I'm talking about magnesium, magnesium is a second group element, this is group number two. And aluminium is third group element, right? And silicon belong to fourth group, okay, or we say 14th group, right? So these are the element and their group. Now, you have to identify the ionization energy. We know now as we move from left to right in the periodic table, the size decreases, right? And we move down the group, the size increases. And we know that ionization energy is inversely proportional to size. Okay, ionization energy is inversely proportional to size. If the size is more, then the ionization enthalpy will be less. So, okay, so if I'm talking about from left to right, that is from sodium to silicon, the size of silicon is supposed to be smaller as compared to aluminum, magnesium, and sodium. So silicon having more ionization energy, right? So silicon, among these four, silicon possesses highest ionization enthalpy as compared to the three other elements, right? Okay. But if I'm talking about aluminum and magnesium, so expected ionization energy for aluminum and magnesium is what? So this is one the expected one according to the size. Okay, expected ionization energy of aluminum is more as compared to magnesium. Okay, why this is because the size of aluminum is smaller. That's why the ionization energy of aluminum is supposed to be high. But in actual fact, not only the size who decide ionization energy. Ionization energy depends upon the several factors, and here one important factor which basically decide whether the ionization energy is low or high is electronic configuration. So if I'm talking about magnesium, it having 1s2 electronic configuration, where aluminum belong to 13 group having ns2 and np1 type of electronic configuration. We know that fully filled and half filled electronic configuration are much more stable. Okay, that's why in magnesium they having 1s2, and we know now s, when s is fully filled, because s orbital has only 2 electrons, so 1s2 having fully filled electronic configuration, and due to this magnesium possesses more ionization energy than aluminum. What we expected, beta, aluminum should possess, but in reality when we compare also the electronic configuration, then in reality which possesses highest ionization enthalpy, that is magnesium, even their size is bigger than aluminum. Okay, just this point must be remembered. So what is the correct sign, beta? What is the correct sequence? Minimum ionization enthalpy sodium, right? And next is aluminum. After this, magnesium, and maximum is for silicon. So this is the correct order. So identify the correct order from the given option. That is option number A, beta, right? Option number A is absolutely correct. That is sodium having minimum, or we say least ionization enthalpy, where magnesium having ionization enthalpy more than aluminum and sodium, and less than silicon. Okay, so these are the correct options. That is option number A. I hope I am clear. Everyone, beta, please. Yeah. So this is the correct answer for this question, right? So this is the simple question, and many times these type of questions are coming in your examination related to ionization enthalpy, and you have just arranged them according to the order. So what is the key concept here, beta? The key concept is, first of all, you need to know which element belong to which group. If you know this now, this will really help in your preparation, right? Okay. Now, चलो देखते हैं हम next क्या है हमारा. तो next question is very very interesting, and it's a very important also, and a बहुत ही simple question है. That is, what is the CFC for octahedral is given. What is the CFC of tetrahedral? Right. So this is the relationship between the splitting energy. So we know that for the, what is the relationship between splitting energy in terms of octahedral and tetrahedral? What we know better, that is splitting in tetrahedral is 4 by 9 times to the splitting in octahedral. यानी tetrahedral में जो splitting होती है, which is very 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 minimum as compared to the splitting in the octahedral, right? Okay. And this is the relationship between these two, that is a splitting in tetrahedral and in octahedral. So just use this simple formula and calculate by using this, because we know that na, this is 4 by 9 and delta O is given, that is splitting in octahedral is already provided now. How much, beta? 18,000. So just put it here, right? 18,000. So what is the value? 92. Okay. So 2 for the 8,000. So 8,000 is the correct answer, right? So I hope ये सबने ही किया होगा. बहुत simple question था, and most of you can do this question correctly, right? So the correct answer is 8,000. And this question belong to which chapter, beta? Yes, coordination chemistry. And under which topic, beta? That is splitting. That is crystal field splitting energy. So this is the simple question. Now, let's move to the next question. That is question number 34. This question is basically from metallurgy. Okay. So what the question asks, beta? Zone refining is based on the principle that. Okay, so you have a 4 option, right? So out of this 4 option, which one is correct, beta? How many of you do this correctly? Yeah, how many of you did this? Okay, so question number 34, they ask, zone refining is based on the principle there. What is the principle behind the zone refining? देखो zone refining को ऐसे समझ सकते हैं, झाड़ू लगाते हैं ना घर में जैसे, तो क्या करते हैं, किसी चीज से झाड़ू लगाते हैं, क्या लगाते हैं, और इम्प्योरिटी को एक जगह पे इकट्ठा कर देते हैं और उस चीज को वहां से कट कर देते हैं. तो ये प्रिंसिपल होता है पूरा जोन रिफाइनिंग का. ओके, गॉट इट. कि किसी चीज को इम्प्योरिटी आर अरेंज इन अ वन साइड, इकट्ठा कर लो इम्प्योरिटी को एक साइड पर, वहां से उसको कट करके अलग ही कर दो उस पार्ट को। तो इस तरीके से पूरा रिफाइनिंग काम करता है। तो बेसिकली व्हाट इज द जोन रिफाइनिंग? तो जोन रिफाइनिंग इज बेस्ड ऑन द प्रिंसिपल दैट impurity are more soluble in the molten metal than in the solid metal. If I'm talking about the molten metal and the solid metal, then the impure solubility of impurities are totally is more in molten metal as compared to the solid metal, right? So option B, this is very easy question, right? And based on the zone defining, that is impurities are more soluble in molten metal as compared to the solid metal, right? Shall we move to the next question, beta? Yeah. So this question, student facing some problem in this question, and this is a very interesting question. And I can't say this is an easy question, but it is a concept-based question. If you know the concept behind this, then you can solve this. Now, I'm going to explain you after this. Whenever these type of questions will come in the exam, you are able to solve this question, right? So many of the problem, I saw the result. Many of the students are facing problem in this particular question, right? So let me explain this question. First of all, read the question very carefully. Okay, then you only got to know what to do and how to start the question solving. Okay, so in this question, 2 moles of mixture of O2 and O3 are reacted with the excess of acidified solution Ki, and the iodine liberated require 1 liter of 2 molar hypo solution. So first important note here is na, what is hypo solution? This, what is the formula of this? Many of the problem facing in this problem, this is what is hypo solution, sir? What do you mean by this term hypo solution? So try to learn the formula of hypo solution. Hypo solution means what? That is Na2 S2 and O3. So hypo means Na2 S2 and O3. For the complete reaction, what is the weight percentage of O3 in the initial sample of X? Okay, you have to find the value of X beta. We know that how to calculate the weight percentage. So in any numerical question, what is the basic rule to start the question? First of all, just write what the question asks, what they want from you. Okay, so in this question, what they want, beta? The weight percentage. So first of all, in step number 1, just write what the question asked. Okay, so in this question, you have to calculate weight percentage. So we have to calculate weight percentage of O3. So how can you calculate this beta weight percentage of O3? If we know the number of mole, okay, if we know the number of mole, yani what we need to know that O3. So if we have know the number of mole of O3, that is number of mole, right, and multiply by its molar mass. So we know the number of moles, right? Okay, so if we know the number of moles and molar mass, then what you know? Mass of the particular component, है ना? So weight percentage means what? You have to calculate the mass of, just like ना, जैसे निकालते थे mass of the solid upon में total mass into 100. This is only the formula for calculating weight percentage. So this question is simple. Okay, just you have to calculate the weight percentage, and it's not difficult, like weight of the particular amount upon my total weight into my 100. So for weight, what you need? You know the molar mass of O3. If you know the number of moles, then the number of mole into molecular mass is equal to mass, and upon total weight, or we say total mass, into 100. So this you need to know. So this is our requirement. So the main issue here, you have to calculate the number of moles here. Okay, once you calculate the number of moles of O3, then you are able to solve this question. Okay, so you know what we have to calculate in this question. First of all, weight percentage of O3 only. Now start how we can calculate number of mole of ozone. Okay, so now read the question again. Okay, and we came back to the equation number 1 after some time. Okay, so 2 moles mixture of O2 and O3 is reacted with excess of acidified solution of Ki. यानी Ki के साथ कौन रिएक्शन कर रहा है? तो Ki के साथ रिएक्शन कर रहा है अपना O3. तो बेटा जब Ki की तरह O3 रिएक्शन करेगा तो क्या बनाएगा? तो ये बनाएगा I2 plus H2O and plus O2, right? Ki plus O3 gives us I2 plus H2 plus O2. Now अगर मैं मान के चलूं कि यार यहाँ पे वैलेंसी फैक्टर मेरा कितना है, ठीक है, यहाँ पे वैलेंसी फैक्टर मेरा कितना है। तो ये देखो यहाँ पे ऑक्सीडेशन स्टेट क्या आएगा, कितना है, माइनस है। और यहाँ पे कितना आ गया, ये जीरो आ गया है। कितने का चेंज हुआ है बेटा, -1 से 0, दैट इज 1 का चेंज हुआ है। और यहाँ पे कितना हो गया टोटल, तो दिस इज, अगर मैं बोलूं कि यहाँ पे मेरा वैलेंसी फैक्टर 2 है, और यहाँ पे भी वैलेंसी फैक्टर कितना है बेटा, 2 है। और इसके मोल को, जो ओजोन है ना, ओजोन के मोल को मैं एन मोल एज्यूम कर लेता हूँ। तो इसके मोल को कितने मोल एज्यूम कर लेता हूँ मैं, एन मोल। तो लेट द नंबर ऑफ मोल ऑफ ओजोन इज एन, राइट। नाउ एन मोल ऑफ दिस, ओके, बोला है क्वेश्चन में कि द आयोडीन लिबरेटेड, जो आयोडीन इसमें लिबरेट हुआ है, मतलब जो निकला है, रिक्वायर 1 लीटर और 2 m हाइपो सोल्यूशन। उसको कितना रिक्वायरमेंट है, 1 लीटर और भी से 2 मोलर हाइपो सोल्यूशन। यानी दिस आयोडीन I2 react with the hypo solution. Hypo means Na2, H2 and O3, and this will gives us 2I plus what value beta, 2I plus Na2, S4 and O6. Okay, here also what is the valency factor beta, jaldi bataiye. Here the valency factor is also, valency factor is 2, and here also valency factor is 2 because there is a 2 iodine molecule, no? So this will convert into 2I negative. So here I is equal to 0 and 0 say -1. There is one change. So for the 2 iodine atom, their total change will be 2, right? So now you can write from the law of equivalent, law of equivalent. What is the law of equivalent state? Okay, beta. So according to law of equivalent weight, that is equivalent of O3, that is equivalent of O3 is equal to equivalent of I2, right? That is equivalent of O3 is equal to equivalent of I2, and equivalent of I2 itself equal to equivalent of hypo solution, right? And this will be equal to equivalent of hypo solution. Now we know that equivalent of O3. What is equivalent of O3 beta? How can you calculate equivalent now? We can calculate equivalent by multiplying the valency factor with the number of moles, right? So equivalent of O3. So let the number of moles of O3 will be n, we assume already. And what is the valency factor of O3 beta? 2. So n into 2, 3. What is this equivalent weight of I2, which is equal to equivalent of hypo? If I'm considering about the hypo, already given a 2 molar. Okay, so their mole is already given, that is 2 mole. So this is 2 into 1 into how many change? It is 1. That is from here to here, only 1. That is just observe carefully. Na2 same, SO3 same, just Na2S4O. Just oxidation state of sulfur is changing. That is 1. It means what is N comes out to be beta? N comes out to be 1. So what is the mole of O3 beta? 1. So if you know the mole of O3, that is comes out to be 1, just put the value here. That is number of mole, that is 1. Molecular mass is equal to 48 upon yes, upon 1 plus 1 into 48 plus 1 into 32, right? 1 into 32. That is the total mass. Okay, oxygen plus ozone. So what we get this beta? By solving this, we can get the answer. That is 60. So 60 is the correct answer for this question. For question number 35, 60 is the correct answer. I hope समझ आया सबको ये? ओके, एक बार और एक्सप्लेन कर देता हूँ कि कैसे हम लोगों ने इसको फाइंड आउट किया है, राइट? सो first of all, in this question, they were asked to calculate the percentage weight of the O3 in the initial sample of X. Okay, so for this, we know that if we want to calculate the percentage weight of O3, then what we need, that is the weight of the O3 upon my total weight of the solution into my 100. Okay, this we want, na? So how will calculate the total weight of ozone? That is the total number of mole of ozone into molecular mass. Okay, now main focus here na ki how to calculate the number of moles of ozone. Okay, once you calculate the number of mole of ozone, then you can easily calculate the percentage weight of O3. For this, we write a reaction. Whenever the Ki react with O3, it produces I2H2O plus O2. Now we know that the valency factor of O3 is equal to 2 and the valency factor of Na2SO4O2, that is a hypo solution, is also 1. So according to the law of equivalent, equivalent weight of O3 is equal to equivalent of I2 is equal to equivalent of hypo. According to this equation, we can observe this. Now how to calculate equivalent? That is multiply mole by the valency factor. That is n into 2 is equal to 2 into 1 into 1. So here we calculate n is equal to 1. And we find just as we soon know the number of mole, we are able to calculate the percentage weight of O3, right? So this is how we can calculate this. I hope is it clear to everyone? Okay. Shall we move? Good. Now, in question number 36, what they ask? Which of the following pair of ions are isoelectronics? Okay, which of the following pair of ions are isoelectronic and isostructural in nature? There are options given. What do you mean by this term isoelectronic, beta? Isoelectronic means same number of electrons. If they contain same number of electrons, it means they are isoelectronic in nature. And isoelectronic means what, beta? Their hybridization should be same. Their hybridization should be same. So out of this four, which one shows same number of electrons and having same hybridization? So if I'm considering about CO3 and NO3 2 negative, right? If I'm talking about CO3 and NO3 negative, how many electrons they having here? Batao jaldi. CO3 twice negative. They having carbon having how many electron? Carbon having molecular mass 6, so 6 proton, 6 electron. Oxygen 8 3s are 24 and plus 2. So it comes out to be 32 electrons. So they will contain 32 electrons, right? And similar way, if I'm talking about NO3, N having how many electron? 7. O having 24 plus 1. Again, it comes out to be 32 electrons. So both having isostructure in nature. That is CO3 and NO3. And both having same hybridization as well. That is sp3. Right. So both having same hybridization and both having same number of electrons. If I'm talking about NO3, what is the hybridization of NO3, beta? NO3 having hybridization sp2. Okay, so NO3 negative having hybridization sp2. Similarly, CO3 also having hybridization, beta, sp2. So they both are isostructural and isoelectronics in nature. Now, which pair is the next? That is pair number 4. That is ClO3. ClO3 negative and SO3 twice negative. If I'm talking about ClO3, Cl having how many electrons, beta? Chlorine having 17 electrons plus oxygen having, yes, 8 3s are 24 plus 1. This comes out to be 42. Similar, if I'm talking about SO3 now, so SO3 is 16 plus 2 plus 24, that is 42. They are also isostructural in nature, but their hybridization, that is sp3, and they are having also sp3. So compound number 1 and compound number 4, these two are isoelectronics and isostructural in nature. Okay, so these two are the correct statement. Okay, okay, better. So this is the correct explanation for this question, right? Okay, shall we proceed to the next question? Yeah. This one is also very important question. Most of the students are facing problem in this question also. Okay, so how can we solve this question better? First of all, just read the question very carefully. Okay, what the question asks. Okay, for in this question, 0.01 mole of the gaseous compound C2H2OX were treated with 224 ml of O2 at STP. It means 0.01 mole of a gaseous compound C2H2OX was treated with 224 ml of O2 at STP. After combustion, the total volume of the gas is 560 ml. यानी जब combustion हो गया, after combustion the total volume of the gas is 560 ml at STP. On treatment with KOH, the solution volume, the solution KOH solution, the volume decreased to 112 ml. The value of X is, you have to calculate the value of X here. Okay. So how will you solve this, beta? Okay. Let me solve here only. Wait for a minute. Okay. So now, according to this question, 0.01 mole of a gaseous compound, okay, and react with. So here, what is the key point here? Now you have to calculate the volume X, right? So now volume of CO2, that is volume of CO2 plus volume of remaining oxygen plus volume of remaining oxygen, remaining oxygen is equal to how many? Already given beta 560 ml. That is 560 ml. So this is the volume of CO2 plus volume of remaining oxygen, which is equal to 560 ml. Okay. Now, according to this reaction, that is C2, H2, and OX react with 5 minus X by 2 mole of O2, and this will produce 2 CO2 plus H2. What will they produce? 2 CO2 plus H2. Right? Okay. Now, C2H2OX. We have what we have to calculate, beta. We have to calculate the value of X. So how will you calculate the value of X, beta? Okay. If I'm saying for the used mole of O2, how many? That is 5 minus X upon 2. How many mole of O2 are used? That is 0.1. That is how much? 0.01. Okay. This will be 0.1. Okay. We have to write again, right? Okay, no issue. दोबारा कर लेते हैं एक बार, है ना? Just remember this one important thing. That is total volume. That is the volume of CO2 plus volume of remaining oxygen. Remaining oxygen. Right? Volume of CO2 plus volume of remaining oxygen is given, that is 560 ml. Right? At STP. Now, according to the reaction, that is C2, H2, and OX, and this will react with 5 minus X upon 2 moles of O2 to give 2 mole of CO2 plus H2. Now, according to the question, क्या given है भाई कि 0.01 mole, 0.01 mole, that is for the use mole of O2, for the used mole, for the used mole of O2. For the used mole of O2, this will be 5 minus X upon 2 into 0.1 is equal to what, beta? 0.01 upon 2. This is already given, right? So on solving this, what the value of X comes out to be? X comes out to be 4. So here, what is the X, beta? X is equal to 4. So the correct option is option number 1. That is 4. So if you know the reaction of this question, then you can, then only you are able to solve this question, right? So the correct answer is 4. Now, Move to the next question. That is question number 38. Which of the following reaction is disproportion reaction? What is disproportion reaction, beta? Disproportion reaction are those reaction in which both oxidation and reduction takes place. Okay, in which both oxidation and reduction takes place. Okay, so these are the those equation, those reaction in which oxidation reduction takes place simultaneously. If I'm talking about this question now, out of this copper MnO4 NH plus, which will show this better. Okay, if I'm talking about copper plus in aqueous solution, okay, if I'm talking about copper plus in aqueous solution, whether it show disproportion reaction, whether it show disproportion reaction or not, yeah, it will show. Okay, so ये show करेगा, definitely करेगा. Okay, how will it show, beta? Copper in aqueous solution form copper plus copper 2 ion, right? In aqueous solution, it will form copper as well as copper 2 ions, and this will show disproportion reaction. For example, a copper plus in aqueous, they will form copper plus 2 and copper. Here the oxidation takes place, that is plus 1 2 plus 2. It means oxidation takes place, and also the reduction takes place, that is plus 1 to 0. So in this reaction both oxidation reduction takes place, so we can say that this is an example of disproportional reaction, right? Okay, on the similar basis, if I'm talking about equation number 2, right? MnO4 2 having, MnO4 2 having. What is the oxidation state of Mn here, beta? That is x minus 8 is equal to minus 2. So x comes out to be 6. Here the oxidation state of Mn is 6. Now whenever the MnO4 react with H plus, so what happened, beta? MnO4 react with H plus, they will produce MnO4 negative plus MnO2 plus 2H2. Just balance this. That is 3MnO4 and this is 4H plus. So here also now, if I'm calculating the oxidation of manganese here, what comes out to be this? This will be X minus H, that is the plus 7, and here plus 2. So whether the oxidation state increase or decrease, both are happening. For example, here the oxidation state of Mn is plus 6, and this they converted into plus 7. So the oxidation state is increased by factor 1. And also from 6, it will become 4. There the oxidation state decreased by 2. So in this, both oxidation and reduction takes place. So option A and option, sorry, state 1 point and number 2 point, both are correct. It means option A is absolutely correct for this answer. Okay, so what is the correct answer for the 38 beta? 38 question? That is option A. Option A is absolutely correct. Okay. Okay. Now, what question number 39 asks, beta, this is a very simple question, and I hope many of you solve these questions without any problem, right? So first question, that is question number 39, is by adding gypsum to the cement, what the gypsum do? Okay, what is the role, what is the application of the gypsum in the cement? So by adding gypsum to the cement, what happened, beta? Setting type of cement become less, setting time of cement increases, color of the cement become light, or shining surface is obtained. Which one is correct? I know most of you do this question, did this question very easily. You know, this is the easiest questions. Okay, so correct option is, correct answer is B. That is setting time of a cement increases. Whenever you add gypsum to the cement, na, so what happened? That is the setting time of cement increases, right? The next question is on heating ammonium dichromate. Okay, on heating ammonium dichromate and barium azide separately, we get what? If you decompose the ammonium dichromate, then we get N2 gas. And similar, if we decompose barium azide gas, then also we get N2 gas. And in both cases, N2 is produced. Okay, so N2 in both cases. So what we get, beta? N2 in both cases, right? Next question, that is question number 41. value of Henry constant Kh increase with increase in temperature, decrease with increase in temperature, या greater for gases with a higher solubility, या constant for all gases. So what is the correct answer, beta? We know that according to Henry's, what is Kh, beta? Yeah, you know, the solubility factor is equal to what? By knowing the Henry constant, that is Kh. If we know the value of Kh now, then you can also calculate the solubility, whether the what the Henry law state that is the amount of a gas dissolved in a liquid is directly proportional to the partial pressure. Okay, so what is the value of K here, beta? With increase in the temperature. If you increase the temperature, then the value of KH is also increasing. Okay, so value of KH is directly dependent upon temperature, and if you increase, then the value also increases. Okay, okay. Now, next move to the 42. Here the correct answer is A. Next move to the 42 question. That is, which of the following is an example of absorption? So this is from surface chemistry, and you need to write the correct option. Which of the following is an example of absorption? Okay, so which of the following is an example of absorption? Yes, better. Which of the following is an example of absorption? Yeah, water on silica gel, water on calcium chloride, hydrogen on finely divided nickel, yeah, oxygen on metal surface. So, which of the following is an example of absorption? Yes, beta. That is option number B. That is water on a calcium chloride. Water on a calcium chloride is an example of absorption. Okay. Now, question number 43. This one is also very important question, and basically, this question from aldehyde and ketone chapter. Okay, so you have to identify the reactant XY of the following. So observe XY. What is the reagent we use? That is a base in presence of aqueous. That is dilute alkalis. So you know where we use this term dilute alkalis, beta? In aldehyde and ketone. Yes, in aldol condensation. In aldol condensation. Condensation. So first hint here for this question is it is already given, that is a dilute base. So this is the first hint which indicates this reaction must be aldol condensation. And what is the second hint? We know that in aldol condensation, formation of beta hydroxy aldehyde or ketone takes place. Here also, just observe carefully, this is group. So this is the alpha carbon, right? And this is alpha carbon and this is beta carbon. So this is the formation of beta hydroxy. So this also tell us clearly this question belong to aldehyde group, and it is basically from aldol and aldol condensation. Okay, so in this question, what the value of X and Y they are asking. So what we use, we use as a reactant in case of aldol condensation, beta? Either we use two same aldehyde, two same ketone, or one aldehyde and one ketone, or two different aldehyde or two ketone, right? So here what is X and Y? Question number 43. So here X is definitely benzaldehyde, beta, and this one is acetone. Option B is absolutely correct. Okay, so option B is absolutely correct. That is benzaldehyde and acetone. So benzaldehyde and acetone is the correct option for this question, right? Okay. Now, next move to the next question. That is a 0.2%. Okay, 0.2% of phenol. This question is from chemistry in everyday life. Okay, so 0.2% solution of phenol act as what, and 1% solution of phenol act as what? You have to identify the correct answer. Yes, beta. बहुत simple question है. जल्दी से बताओ which option is the correct one. 0.2% solution of phenol act as a what? Disinfectant or antiseptic? Yes, beta. 0.2%. When the concentration of phenol is very less, na, then it acts as an antiseptic. When you increase the concentration of phenol, then it becomes disinfectant. We use in our day-to-day life for our house cleaning, floor cleaning, toilet cleaner, है ना? So 0.2% solution of phenol act as antiseptic, where the 1% solution of phenol act as a disinfectant. Okay, so which option is correct, beta? That is option number A. Okay, so this is the correct answer for this option. Now, what is the major product of the following reaction sequences? You have to calculate the major product for the following reaction sequence. Okay, so first reactant is given, that is a B2H6 diborane, and the next step H2O2 with NaOH, and with the third step concentrated H2SO4 when heated, concentrated H2SO4, right? So let's discuss this. Okay. Okay, first of all, this is treated with B2S6. We all know that B2S6 attached in this double bond, right? And the formation of what takes place? Yes, triboric. Okay, so this is देखो ये 3 times alkyl group हो गया, तो trialkyl borane. तो 3 alkyl group लग गया और ये आपका borane है. Now, next, this is treated with next step क्या था? H2O2 and NaOH. H2O2 and NaOH. Then the formation of phenyl OH takes place. In the next step, treated with concentrated H2SO4. We know that whenever we treat with concentrated H2SO4, dehydration takes place and the removal of water molecule takes place. So, यहाँ से OH और एक H निकला, तो क्या मिल गया? H2O निकल गया. So, formation of this will takes place. So, which option is correct, beta? Out of this 4? Yes, A, B, C, D. This is the final product, right? This is the, so which option is correct, beta? This one, that is option number C. So this is the absolutely correct option for this question, right? Okay. Next, question number 46. This is another very important and very simple question. This question is from amine chapter. I hope everyone did this question. This is very simplest question, right? So identify the Y and Z in the following reaction. So we know that whenever the aniline is treated with NaNA2 and HCl, then the formation of BDC takes place. So here X is BDC, nothing but BDC. What is BDC, beta? That is benzene disonium chloride. So here BDC is benzene disonium chloride. Now, when this BDC is treated with the H2O and heated, then the formation of phenol takes place. Then the formation of phenol takes place. And when the phenol is treated with chloroform and strong base like NaOH, KOH, then the formation of salialdehyde takes place. Then the formation of what? That is the formation of salialdehyde takes place. Right? So which option is correct, beta, for this question? Y is what? So this is our X, right? So you have to calculate Y. This is Y. This is Y. This is Y. And this is Z. So Y is phenol and Z is salialdehyde. It means which option is correct? That is option number A. So option number A is the correct answer for this question. I hope, is it clear to everyone? Yes. Right? So you have to identify the Y and Z in the following reaction and you saw the solution for this chapter. Okay. So I hope, is it clear to everyone? कैसे आया ये सबको समझ आ गया? Right. Okay. Now, next move to the next question. That is question number 47. Which of the following is the most reactive cation according to the reaction with phenol in a basic medium? Okay. So which of the following is the most reactive reaction in azo coupling? Okay. Azo coupling. What is this azo coupling reaction, beta? Whenever BDC is treated with, whenever BDC, right? That is N2Cl is treated with phenol. is treated with phenol, then formation of azo compound takes place. Removal of HCl and formation of what beta? Azo compound takes place. Right? This is called azo compound. Okay? Azo. Okay. Now in this question, which of the following is the most reactive cation in accordance in a cation in azo coupling reaction? This reaction is also known as a coupling reaction, right? With the phenol in a basic. So which one is beta? Yes, 47. So which one? That is this. Why beta? Why this one is more stable, most reactive cation in azo coupling? Because here N having positive charge, right? And having double bond. And we know that benzene in aromatic compounds, whenever the electron withdrawing group increase, whenever the electron withdrawing group is attached to the benzene, it increase its stability. Okay, so NO2, because NO2 here is what? This is electron withdrawing group, where all other, that is CH3, Cl, they Cl through resonance it donate electrons. So these are not the electron withdrawing group. So due to presence of electron withdrawing group in NO2, these are much more stable. Okay, so which of the following is the most reactive cation in azo coupling reaction with the phenol in basic? This one. Okay, that is NO2. Right? Okay. Now next move to the next question, that is question number 48. This one is also a very, very good question. In this question, what they ask beta? They ask, given the structure is given and you have to react with this with NaOH. Okay, so what is the correct answer for this? Let's discuss. When this is treated with NaOH, what happened now? NaOH behave as a nucleophile. NaOH behave as a what? That is a nucleophile. This ONA and the removal of what takes place beta? HBr. So Br is removed, and as soon Br जैसे यहाँ से remove हुआ, they having a lack of electron, and this O comes to this position and donate electron to this. So what the formation takes place beta? The formation of these being placed. Okay, because NaOH here act as a nucleophile. So the correct option is option number B. So B is the correct option, right? Okay. Now this is also very important question. That is when the A is treated with phosphorus plus Br2, the formation of B takes place. And B react with this KOH, NH3, KCl, and H2O to form this. What is A here? So this is simple question. Whenever the A is treated with the KOH, NOOH, NH3. Okay. So it will form what? It is basically carboxylic acid. Whenever the carboxylic acid is treated with P plus Br, it form what? Which react with KOH alcoholic, NH3, KCN. So here we know that CH3, CH2, COH, and this is a very famous reaction, that is HBZ reaction. Right. So this is HBZ reaction, and this will produce CH3Br, and this will give the further reaction. So here A is CH3COH, that is propanoic acid. Okay, right. So here H is propanoic acid, right? Okay. Now, in this question, that is the final product of the following reaction is. We know that as we saw the reagent, we identify this is a Rosenmund reaction. This is a Rosenmund reaction, because in Rosenmund we use this catalyst S2PD plus BaSO4. In Rosenmund reaction, what happened? That is when acid whenever we treat acid chloride with the reducing agent, then the formation of aldehyde takes place. So only aldehyde is prepared by this method, not ketone or any other. So which option is incorrect beta? Alcohol. There is no possibility of formation of alcohol. No. So only aldehyde is produced. So which option, A or D? Which one is correct? What is the final product of the following reaction? Only aldehyde group or double bond and aldehyde? Okay. So this is double bond with the aldehyde. So which option is correct beta? That is for question number 50. D option is absolutely correct, right? So correct is D. Now This is very important question. That is question number 51 and 52. Let me discuss 52 first. Then after we'll start discussing 51. Okay. So because 52 is very simple question and it's just a formula based question. Just need one simple formula. And if you know this formula, then you can easily calculate this. According to question number 52, the Boyle's temperature of the van der Waals gas is given. That is minus 246 degrees Celsius. Its critical temperature on absolute temperature scale is, what is its absolute, if the critical temperature on absolute temperature scale is what? So we know the relation between critical temperature and Boyle's temperature. What is the relation, beta? The relation between the critical temperature and Boyle's temperature is this. Critical temperature is 8 by 27 times of Boyle's temperature. So this is the relationship between this. That is, the critical temperature is 8 upon 27 times of Boyle's temperature. Now, we know 8, we know 27, we know Boyle's temperature as well. What is the Boyle's temperature here, beta? This is minus 246. We convert this in Kelvin, we'll get 27 Kelvin. Okay, so just put it here, 27, 28 cancel, just 8 left. So what is the correct answer, beta? That is 8 Kelvin. So 8 is the correct answer for this question. So, kitna easy tha question ye? If you just know the formula, what is the relation between the critical temperature and the Boyle's temperature, na? Then you are able to solve this question, right? Okay. So this is the desired answer for this question. Now, next move to the question number 51. Okay. And this one is a very important question to try to focus on this, how to solve this question. I'm going to explain in a very deep way. So इसको ध्यान से देखना बेटा कैसे solve करेंगे. Okay. So what the question asks ना, given two separate reaction, one A product, two B क्या दे रहा है हम लोग को product. Reaction 1 follow first order kinetics while the reaction 2 follow second order kinetics. मतलब first का order 1 है, second का order 2 है. Both the reaction have a half life. Both reaction के half life है. When the initial concentration of A is n times that of B, then the rate of reaction of 1 is 1.38 times that of rate of reaction at 2 at the start of the reaction. The value of n is okay. So just remember two products hai, 1 and 2. One follow first order and second follow second order. Okay, now let's discuss the solution. If I'm talking about A, rate is equal to Ka because they are follow first order kinetics. So rate is equal to Ka. Now what is the half lifetime for the first order reaction beta? We know that T half is equal to 0.693 upon Ka. And for the B, it follows second order kinetics. So the rate is equal to Kb into B2. What is the half life? That is 1 upon AKB. Where is the concentration of A? Where A is the concentration of B at the start of the reaction. Right. Now, since the half-life are same, since for both the reaction it is given, half-life are same. So here we can easily calculate the ratio of Ka by Kb and it comes out to be 0.693A. Now, since the initial concentration of A is n times that of B, यानी initial concentration जो A का था वो n times of B था, that is Na. So Ra upon Rb is equal to K upon Kb into Na upon A square, and given this is Ra upon Rb is what? That is 1.386. This is already given. So just put the value and you can easily calculate the factor n here. So here n comes out to be 2. So what is the n here, beta? 2. So according to the question, just follow this. It is already given. That is when the initial concentration of A is n times of that of B, then the rate of reaction is this times of that of reaction 2. It means 2 upon 1 is 1.386. It is already given. So by just putting the values, you will get the desired answer. That is n is equal to 2. So this is the desired equation for this question. Right? I hope is it clear to everyone? Okay. Now, the next question is very important and this is basically based on before 53, we are going to discuss 54 question because these are important and they are easily discussed, right? मतलब बहुत जल्दी समय में इसको कर सकते थे और ऐसे क्वेश्चन बहुत आते हैं तो इसके लिए तुम्हें बहुत फोकस करना है बेटा. क्या है ऐसा क्वेश्चन? चलो देखो. इन द गिवन रिएक्शन गैसेस PQR SR प्रोड्यूस. ओके, सो इनका रिएक्शन जब कराते हो तो आपको कौन कौन सी गैसेस मिल रही है? P मिल रहा है, Q मिल रहा है, R मिल रहा है और S मिल रहा है. इफ द टोटल नंबर ऑफ एटम प्रेजेंट इन पर मॉलिक्यूल ऑफ द गैसेस आर X, अगर उसमें टोटल नंबर ऑफ एटम X है, देन डिटरमाइन द वैल्यू ऑफ X - 7. तो सबसे पहले व्हाट यू नीड ना, फर्स्ट ऑफ ऑल ये देखो कि इनका रिएक्शन हो रहा है तो मिल क्या रहा है, इस पे फोकस करना अभी बस। तो B2H6 plus H2O will give H2. Similar when you treat KO2 plus H2O, you will get O2. Now Al43 will get CH4 and C2H2. So one molecule, two molecule, three molecule, four molecule. How many atoms having the H2 molecule having two hydrogen atom, O2 molecule again having two oxygen atoms, CH4 having 5 atoms, C2H24 having 4 atoms. So the total number of atoms 2 to 4, 4, 4, 8, 8, 4, 5, 13. So total number of atom beta comes out to be 13. So here X is 13. So what is X here? 13. 13 minus 7, it comes out to be 6. So what is the correct answer for this question beta? That is 6. So 6 is the absolutely correct answer for this question. Right? Now discuss question number 53. What 53 asks? A metal S is added to excess of 500 ml of 1 molar solution of the another metal of B ion 25 degrees Celsius until the equilibrium achieved. Now, given equilibrium, the concentration of Bn is this much, and you have to calculate the value of N. What you have to calculate, beta? You have to calculate the value of N. Okay? So this question is basically from the Nernst equation. By using Nernst equation, you can calculate this question, right? So how will you calculate this, beta? First of all, we know that what is Nernst equation. So according to the Nernst equation, EMF of the cell is equal to E naught cell, right? Minus what? Minus 0 point, okay? Minus, if you want to put the value also, na, you can also put the value also, okay? So this is NF upon RT, NF upon RT. And here what? That is concentration of product upon reactant. But we know that at equilibrium, E cell become 0. So what is the value of E cell? E cell become 0, right? So just use this. We know that S plus B, it gives us S plus B again. Now, if I'm considering at initially moles at T is equal to 0, when the time is 0, the moles of S is 0.5, where the mole of this is 0. Now at equilibrium. So what happened at equilibrium, beta? Just try to explain this again. Just try to look. This is a S, which is in solid form, and this react with the B, which is in aqueous form. Okay, this is in aqueous form, and this will gives us Sn plus and B solid. Okay, if I'm talking about at T is equal to 0, initially when the time is 0, then their mole is what? Then it is already given their mole is 0.5 and product mole is 0 because the reaction is not started. When the reaction is started and reaches to equilibrium point, then their mole becomes 0.5 minus x, where x is the degree of dissociation, right? And the formation of X plus X takes place, right? Now, this is given at equilibrium, their mole is already given. How much, beta? 5 into 10 ki power minus 18. So you can easily calculate X here, na? You can easily calculate X. What is X comes out to be? Yes. So you can calculate X by using this. So it comes out to be 0.5. So what is X here, beta? 0.5. Now put this in the equation, that is ECl is equal to EB naught plus E cell minus 0.06 upon N log 10 base to the power product upon reactant. We know that at equilibrium E cell becomes 0. Just put the value 0. Now what is left here? We already provided with this cathode anode values. Now you just calculate this value, that is product concentration is that is 0.5 and Bn concentration 2.5 into 10 k power 18. So you can calculate N here. Okay, where what is N here? Number of electrons that is takes participate in this redox reaction, right? So N comes out to be 2.03. So we can write as 2. Nearest integer we can write as 2. So this is how we can solve this question. So I hope this question is clear to all. या तो ये सारे इंपॉर्टेंट क्वेश्चन थे जो हम लोग को सारे डिस्कस करने थे. ओके, तो दीज आर बेसिकली द मोस्ट इंपॉर्टेंट क्वेश्चंस which having some very deep concept, and by learning this question na, you are able to solve many questions like that. Okay, so just try to focus it. देखो इसको ध्यान से और करो. फिर हम लोग नेक्स्ट में मिलते हैं और नेक्स्ट में फिर हम लोग इसके आगे के जितने भी क्वेश्चन है ना उसको ट्राई करेंगे सॉल्व करने। ओके, टिल टेक केयर। अब नेक्स्ट क्लास में मिलते हैं, वहां पे हम इनको और आगे जो भी हमारा डिस्कशन होगा वहां पे इसको सॉल्व करने वाले हैं।